we have a lot to talk about, so
I'm going to start right on time. If you know me, you know that's very strange. All right. Man. All right, it's 12:20, so we'll start. Hi, my name is Alex Weinert. I'm the VP for Identity Security at Microsoft, and I'm here to talk to you today about the Stormo 558 attack. This is the be nice and you'll be videoed and that sort of thing. And just by show of hands, who here has played, and this is for probably people with white beards, but Mad Libs, the game Mad Libs. Like long car trips? Okay, about half of you. Mad Libs is this game where like you don't really know what the like nouns and adjectives and subjects are going to be when you start, and so you pick some words and then later on like you fill it in and hilarity ensues. And I have the world's least fun version of Mad Libs. It's like the abstract I find myself writing every year, right? And essentially there will be some massive nation state attack. There will be new techniques. And you know, because we really believe that as a security community, we have to share data, like we need to share information and share learnings, we'll talk about it, right? So that's kind of the spirit of this, is we want to talk about it. Now the thing that was funny is when I wrote this abstract, I had this idea, I was like, I should really just save this and then replace the words next year. And then at some point I want to start submitting abstracts where it's just like, I don't know which attack it's going to be, I'll just talk about the latest one, right? Because they, you know, the sort of the advanced persistent threat actors and the really, nation state based and that sort of thing is happening more and more. So this year's talk is about Stormo 558. This is a China-based threat actor that we've been tracking for a while that managed to forge tokens and impact acquisition of customer email for 22 organizations and about 502 individual users, and that's what we're going to talk about today. Now, this is a crime story, right? Like there was a crime perpetrated. Somebody broke in and stole data that they were not entitled to see, right? And so we're going to play this out like a crime story. We're going to introduce you to the scene. You know, you can imagine the camera panning over the foggy city, right? We're going to introduce you to the characters, a little backstory on our players. You're going to see the frenetic, crazy moments of the crime and how that played out, and then we'll get you the detectives on the scene and we'll do the investigation, and finally, you know, to clean up the crime scene, and like any good story, there's a moral at the end. So let's set the scene. Now I understand I'm at RSA, and this is going to be a funny thing to talk about at RSA, but I want to make sure we're all level set. Like, and just bear with me for 5 minutes. We're going to level set on identity and on public key cryptography. For some of you, you can take a nap. Good time to check your mail. For the rest of you, pay attention, because if you don't know, if you can't understand this well, you're not going to understand what happened and how it played out. So public key cryptography, we're going to create keys in pairs. There's a private key and a public key. And by the way, I'm going to use the sandbagging excuse of, I'm trying to simplify some stuff, so don't get pedantic, or get pedantic with me later over a beer. Private keys and public keys created in pairs, and to be useful, the private key has to be kept secret, and the public key has to be public. That's why they call it a public key. We're going to talk about key acquisition and key leaks and key role, and if you're not clear on which key we're talking about, it's going to be important to know that. So private keys are private, public keys are public. That's supposed to be a billboard. You're going to see a lot of that. Okay, so from here, we can do, you know, what do we use it for? Well, one way we can use it is for encryption. Another way we can use it is for authenticity. We can prove that we're talking to the right person, right? That we're reading a message from an authenticated sender. And so the way that that works is if Alice wants to send Bob a message, Alice wants Bob to know that it came from her. So Alice creates a key pair. And being a good citizen, Alice keeps the private key private and the public key public, right? Alice writes the message, uses the private key to sign it, sends it over to Bob. Bob then pulls the public key and verifies the message using the public key, decrypts it using the public key, and that will prove that it came from Alice, right? The public key will decrypt the message, and we know it came from her. So let's get on to identity. We can think of this like a passport office a little bit. Like I don't want to carry my birth certificate and my utility bill around everywhere. So I take it to one agency. They give me a standardized document that I can present at many places, right? So that's my passport. We're going to use this analogy a couple times in this talk. So, I come along with my papers, right? Or I come in with my username and password. I prove my identity. I get back a passport or the token, right? That I can use to show that I am who I say I am to any passport office, or border control agent in the world, right? So that's a standard document, the power of that standard document. The problem is that that standard document can be fake, can be forged, right? So I want to find some way to make sure that you know that this is a legitimate passport coming from a legitimate passport office. And the way we would do that in the passport world is we have a hologram on the passport, and all the border control agents know there's a document they can look at that tells them these are the valid pictures. These are what the hologram should look like. Here's how you test it with a pen or whatever, right? So the equivalent for this is in identity is we're going to use public key cryptography, right? So an identity provider has a public key and a private key. They need to keep the private key safe. They need to publish the public key, right? Going back through the same ritual again, I prove my identity. This time when I get my passport or my token, I sign it, right? The signed token now can be presented to the border control agent who can use the public key to verify that it's a legitimate passport or token. So far, so good? All right. Okay, now, I'm going to start this joke, which is that there are things in life where the answer is one more, right? How many bikes is the right number of bikes? One more. How many guitars? One more, right? And in this case, how many identity providers? One more, right? So we had two at this point in time. In 2016, we had two distinct systems. I am long enough at Microsoft to have some culpability in the fact that we have two. I said this will be trouble, and sure enough. And so the thing that we have is an enterprise system that serves things like Azure and Microsoft 365 and Dynamics, right? And then we have in 2016 the consumer system, which is on the top there, and it does things like Xbox and Skype and Minecraft and that sort of thing. And for this story, the ones that really matter here are Outlook.com, which is the consumer-facing mail system, and OWA, Outlook Web Access, which is the enterprise-facing mail system. So in 2016, we have two of these things. Now, OWA has extensibility points. And the extensibility points here allow it to do some of the things. We're going to talk about that in a second. But the other thing to know here is that the part where we went and we got the public key and we used the public key to verify that we were dealing with a legitimate token, we had a library to help with that called, shockingly, something like Verify Token, right? And that library was in use by both Outlook.com and OWA, okay? And so its whole job was go up to the public key site, get the public key, make sure that the token signature works with the public key. OWA has these extension points. To interact with the extension points, they want to be able to provide functionality for either on-premises servers or cloud capabilities. So you can think of like if you were doing MIME or other kind of functions like that. And so for those functions to work across both on-premises environments and the cloud environments, they had to do token normalization. They might get a token from an ADFS server. They might get a token from us, from Entra. And so to do that, what they would do is this. They would exchange the token that we provided, right? So you can think about exchanging my passport for maybe a Visa, right? And they would hand back to the client or to the user agent an OWA token, okay? And we'll get close enough to the machine for it to animate. There we go. And then the user agent from that point on to interact with OWA would actually pass the OWA token, not the Entra token. All right. Like I say, one more is the right answer. Okay, so we have 3 IDPs in play. We have these libraries. Let's add one more thing to the puzzle. We have a bunch of people in 2016 who are like, I'm a consumer person only. Consumers are one thing, and enterprise is another thing, and never the twain shall meet. Right? But what we see is things like GitHub, where you have a high school student who's writing code, checking in that code, and then having a teacher grade that code, right? And that interaction is I'm using my personal account, my personal consumer account to check in the code, and then I'm using my organizational school account to read the code, right? So we have more and more applications as we kind of get richer in identity and more cloud services that need to interact with individuals. Maybe I'm an individual consultant. I have a little design studio, and I'm doing artwork for your business, right? So those kinds of interactions become more popular and more common, and developers ask us, hey, make this thing easier. So we create this thing called the common endpoint, right? And the common endpoint basically publishes the public keys for both services into one combined endpoint. Okay? So that is identity from about 2018 to 2023 at Microsoft, at a high level. All right, other things that were going on in terms of setting the stage: attacks are getting worse, they are getting more aggressive, there is more compute available to attackers, they're getting more innovative, and the collaboration technologies we have are being used by attackers to level up attacks. That's playing out in identity specifically, where we're seeing kind of this ratcheting up of attacks where, as people move towards MFA, we start defeating MFA. As we move towards phishing resistant, we start doing token theft. And then finally, we see things like the SolarWinds attack in 2020, which is an attack on infrastructure, right? Where we're actually trying to get after the ADFS keys or compromise the servers. And a lot of persistence there, especially by advanced persistent threat actors. And nation-state notifications are plentiful, and we see more attacks by nation-state affiliated groups that are highly funded and highly persistent. So that's our pre-stage or pre-attack stage, right? We have these three identity providers. We have the common publishing endpoint. We have the validation libraries. And then we have advanced and ongoing attacks on infrastructure or on the rise. So let's meet the players. The first player we're going to talk about is our, misspent youth, right? It's Stormo 558. Stormo 558 is a China-based threat actor which operates primarily in the United States, Western Europe, and Southeast Asia, and has particular interests in doing things that are related to diplomatic, economic, legislative activity, right? So that's who these guys are. We've been tracking them under that name since about 2021. Okay, we have interesting things that give us indications of where they're based, and that includes some of the stuff I'll tell you about later, but we have high confidence that they're based in China. We have, you think about, we're committing a bank robbery. I want the special gem or, FIDO token or whatever it is that's in the vault, right? But the vault is in a bank, and so we're the bank, right? We're the ground upon which the attack is committed, in which the crime is committed. And so Entra provides access to these things, and the treasures are held in exchange, right? This is what these guys as espionage people want, is the mail communications. We have a bunch of people who are the defenders, right? And so I guess you could imagine the scene in the crime movie where like the FBI officer shows up and starts talking to the local police or whatever. We too have multiple defender organizations. We collaborate very heavily. I am wearing in solidarity with my friends in DART, the DART logo from a while back. The DART team basically focuses on direct on-premises response with customers. The Mystic team is the team that primarily works on attribution and threat intelligence for persistent actors. And they'll play, each of these will play a big role. We have security teams in most of the product organizations, including M365. And so there's a team that's specialized in doing exchange security. And then the team that I run is ID Fire, and we do the identity-centric hunting. It's forensics, incident response, and eviction for Microsoft, and it's a busy group of people. One of the founders of that team is sitting right there. So it's kind of cool to see Dana here. And then we have our victim, right? And the victim is an organization that I think it's pretty public who it is. I won't name them just by habit. I don't name people, but they have built a dedicated detection algorithm, and that algorithm is running off of mail items accessed. And so they have this very special detection that they're running. And the reason for that is they were impacted by the SolarWinds attack. They were one of the organizations that were hit by that, and they had developed a great deal of sensitivity to mail exfiltration. So they had done some custom detections. With all that set, we can now get onto the crime scene, okay? So what happens? Well, I'm going to tell the story kind of from the lens that I can tell it from, which is mine, right? How I experienced it or how my team experienced it. And so you might get a slightly different, the tour of this from a different team. But what happens is on June 15th, the detection that the company or the organization had built lights up. It detects anomalous activity. And that is resulting from the analysis of logs that are coming from mail items accessed, and specifically these exchange logs that are in the universal audit logs. And it includes this data plus forensics about how they expect people to work in their organization, right? They had some false positives before, so they took a little bit of time to make sure this wasn't a false positive. They decided it was not a false positive, and on June 16th, they called in DART. DART's, again, the local response team. Now, we have a close working relationship with this organization, so, it's kind of a hotline. DART gets involved. They gather forensic information from the attack, looking at the logs and the detections that had happened, and they pass the word to Mystic. Because Mystic, again, is the persistent threat actor, and because of who the organization is and previous engagements, we think we need to be looking for whether we have a persistent threat actor involved here. So at that point, Mystic gets the data, and Mystic does their magic kind of on an ongoing basis. So as they track these threat actors, they're looking for different indicators, techniques and practices and IOCs that tell us kind of who they are and where they are and what they're doing now. Right? Once we latch onto one of these people, we're trying to make sure we stay with them. And one of the ways that Mystic stays with this group is that they're looking at the VPN infrastructure that the actor uses. And the actor uses things, and they have their playbook, their toolbook, and they set things up in a pretty specific way. You'll see the little orange sign there with the Storm 0558 blog. That blog publishes all the IOCs and TTPs that we gathered and how to hunt for this. And we'll go into detail here if you want to, probably not in the next 40 minutes, but later, go and look at the blog. You can learn about all this stuff. But what's important here is that we were tracking nodes. We could watch nodes light up on this VPN and know it was them, right? And we could watch them go out. And this will become important as we go through in time, right? So we have a set of IP addresses that we know are actor-affiliated IP addresses. So as soon as Mystic gets this information, they're like, hey, that's Storm 0558. They know for sure. Now you could ask this question, well, why didn't you watch for it ahead of time and be proactive? And the answer is, we did, but not this deep in the system, right? We looked at the authentication traffic going to Exchange, not at the inside. There's only so much you need to watch or you think you need to watch, right? And so the logging that was being watched was the Entra logging, not the Exchange logging, right? As soon as they see this, though, they say, oh, we missed a source. So they got the data from the Exchange team, and they went and they identified 21 more targets, okay? So we now have 22 organizations that have been impacted. Mystic and DART begin the process of engaging with CISA and other law enforcement and notifying all the agencies. It's called NSN, Nation State Notification, where we have advanced persistent threat actor engagement. So what happens over the next 10 days is that we look at the investigation in kind of a, boy, that's a bummer that happened. Somebody has malware. Like, clearly we have token theft because we know their authentication wouldn't allow for password stealing, but somebody's got malware, there's been token theft, or there's an insider attacker, right? Kind of, this is what we see every day, day in, day out. It's a super common attack pattern. So this is kind of the assumption, is we have a local problem. The Exchange team, so the DART team's on premises trying to figure out who's got the malware, who's the insider, what's going on, where did the token, where did the access come from, right? On the other side, on the Exchange side, they're looking through and saying, okay, do we have any other actor activity? Do we have anybody else using the same pattern of attack? What's going on here? And what we're not seeing is the middle part, which is the Entra traffic, right? But that's, everybody's busy, and we're doing this big burn, and we're figuring out what they're doing and analyzing the traffic patterns. And then we have, this sort of nice breakthrough on the 25th, and we are puzzled and thinking there must be, this must be an authentication that happened a long time ago. And it's faded from the logs, or we had a log failure because logging at high volume can be lossy, right? And so we have a failure, we've just lost the traffic. But then we see this. On the 25th, the actor spins up a node, installs their software on it, and forgets to secure it, right? So typically what we see is we can say, oh, here's the basic tell of what operating system they're using, right? As far as the response we're getting back from these nodes. But in this particular case, it's like, and the door is wide open. It's a public website, right? So at that point, we go and we download the data from the actor, right? And we pull their source code off that node, all right? And we have inside of that, we have this magic tell, which is that we can see the code that they're calling, the APIs that they're calling, right? And they're calling into this thing called get access tokens for resource. And the way that the system stacks up in terms of the calls that are going back and forth between OA and the client and then back in, again, we have that dedicated normalized token for exchange, right? And this is a call that is used, we think, internally, but turns out the actor could call it, right? And by calling it, they're getting and refreshing these tokens. They're bypassing the OA refresh point. So OA has a token refresh, control, and they're bypassing it. So we're thinking, oh, this must be a really old token, right? Let's turn that off, right? That's what happens. So we stop accepting tokens at that point, right? We take immediate action, we push a hotfix, and we say, we're not going to accept this exchange anymore, right? You're going to have to come back to Entra for your tokens. So we push that, and immediately we start seeing actor-generated tokens. And the actor-generated tokens have many things that are weird about them. And the same day that we start seeing those tokens coming in, which is the 27th, we get the call on the identity side, which is, hey, we think we have a problem. Please come look at this. And this is one of these, like, going back through my notes and having PTSD moments, like the moment that I saw this, right? You see this and you're like, we may have a forged token here. We may have lost our private key here, right? It is one of two things I had hoped I would retire before they happened. Like the second hasn't happened yet. I won't even mention it. but this is like the second worst thing that can happen to an identity system. And so at this point, we look at things that we will, over the next couple of days, confirm are true. But you'll see that I have this enterprise passport. I'm going to enterprise land. I'm going to, org land. But I'm stamped with a consumer stamp, right? So to try to get the analogy across for you. And the consumer stamp is really old. It's dated back in 2016. So it's an out-of-use consumer stamp, right? And there's subtle tells throughout this that are just wrong, right? One of which is that we use a special identification sequence. It's subtle, and I'm not going to talk about it now. But the way we stamp our session IDs is unique. And we do that on purpose. And guess what? It didn't match our pattern, right? So we're like this. Everything about this is starting to say, hey, this is a forged token, which means we have a stolen key, right? So at that point, we pull the alarm bell, and we start what's at Microsoft we call the Standardized Security Incident Response Protocol, and we do a SEV0 SERP, which basically means it's all hands on deck. Anybody who can do anything with log analysis or help with security analysis in any way, this is top priority. For every engineering team involved, it's top priority. And we spend the next couple of days running two things in parallel. One is confirming the hypothesis that we have a forged token and therefore a key that's been egressed. And the other is responding essentially as though we do, and then running those things in parallel. So this is a frenetic week. One of the things we do just proactively same day is we say, let's roll the key right now. Get that key out of rotation, the key that we saw associated with the token. So we do that. This is my version. And the thing to point out is the way that you roll the key is you issue a new key, right? So we roll a new key. We get the old key out of rotation. We actually did this a couple of times, and we also rolled enterprise keys as well. I'm not going to talk about that here, but we were shooting things, just round tripping it basically. The second thing we did is we said, wait a minute, why can I accept an enterprise claim that's signed by a consumer token? That shouldn't be. It's IDP1 and IDP2, and I'm accepting claims from IDP2 signed by IDP1. That doesn't make sense. So what's going wrong here? What we identified was that library, which is validate token, right? That library pre-existed the shared endpoint. When the shared endpoint went up, it went up with metadata that said, here is the scoping and the correct use of this endpoint. That was available data, but it wasn't built into the library. So the people who were consuming the library reasonably assumed that we would update the library so that it would work with the new endpoint, right? In this case, the people being the Exchange developers, right? But we hadn't. And so they said, well, we're going to use the new common endpoint. We're going to assume that the library is fine. And it wasn't. And so what that allowed us to do is to go up to, remember the library's job is simple. Go up to the billboard, pull the public keys, and if anything will validate this message, then the message is valid. Right? So the attacker is creating enterprise claims, signing it with the consumer key. The validation library is using the common endpoint, is not differentiating the two things, and it's saying, you're good to go. Right? So that's why Exchange is accepting these claims coming from the enterprise side. All right. So we update the libraries. This is later, right? This is out of the blog. But we update the two libraries publicly as well as privately. and we roll that out across the organization. Exchange puts in their own checking. And then the next week, in terms of analysis, lots of craziness is going on. We analyze the relying party logs for all the Microsoft services. So we offer a lot of services, and there's a lot of logs. And so this is a serious burn. Like this is around the clock, it's 7-0 SERP, which means that there's no downtime. Right? We're rotating people off. They sleep, they get back online. We go from country to country, keeping this stuff going. And we're looking for any sign of the thumbprint for this thing or any sign of the actor activity. So the indicators of compromise, traffic from these endpoints. And we go through all the logs that we have, right? And we do not find any more activity outside of the mail system. We do find 502 consumer accounts that have been impacted. Those consumer accounts all track back to the organizations that were impacted. So it's, for example, if I have the investigator from Team X, I've got their personal account, or maybe they're somebody in their family's personal account, but they were all correlated. They all correlated back. So we do the notifications for that. So we add more notification traffic where we tell the people that they're impacted, and we find no other evidence of the use of the key. Also, we realize the dates are still tight. Like we figured out the key was forged on the 27th. We're still talking about the 27th, right? So things are happening really fast. OWA, once we realize the problem with this offending key, 2 changes are made. One is to not accept consumer keys at all, and one is to explicitly disallow use of that key. So any token issued that routed back to that key is banned in the OWA system, right? At that point, all the actor traffic in the exchange mail system stops, and the same day, the actor switches back to phishing because they have a mission to accomplish, and they're going to do it however they need to do it. So they go right back to adversary in the middle phishing techniques, right? On the 29th, the public key rotation, which we had started on the 27th, completes its worldwide propagation. So remember, we're not doing things in one place, and we have lots and lots of services. They all have to refresh, right? So all the services have picked up. We validate that on the 29th. We also do the same trick in Outlook as we did in OWA. By the 3rd, that change has been propagated worldwide, which is that key is explicitly banned, and we have notifications going if we see any instances of it. Now, it's kind of worth noting that the key we're talking about was in a backup or old role. So nobody from Microsoft was signing with this key. So this thumbprint was very, very evident to us. It wasn't like we had to figure out, was this one legitimate or not. If it was signed with this key, it was bad, because we were not in our systems using this key at all. July 3rd, we're done. All activity is stopped. And at this point, we can kind of imagine that, the police are on scene, and you have the wet parking lot with the rain falling, and right? So that's where we are in our crime story right now. So let's talk about what happened, right? So this is the full mechanics of the attack. The first thing that happens is the actor acquires the consumer signing key. We'll talk about that next, don't worry. Okay? The second thing that happens is they forge an enterprise token using the consumer signing key. They call an essentially internal endpoint to exchange the token for an OWA token. They go use the OWA token to get mail. And then when they need to refresh their token, they bypass the normal OWA refresh, and they keep the token alive using the alternate mechanism. So that's what they're doing. That's how the attack starts, before we start interacting with them, right? And then, basically from the time we detected it and understood it on the 26th to the 27th, it was shut down. So the attack left goalpost is May 15th. We know that because we have their actor infrastructure, we have their source code, right? The right goalpost is the 27th. I'm sorry, I'm using what I'm assuming are terms that we sort of know, but I get scolded from time to time from using security geek terms. Left goalpost when it started, right goalpost when it stopped. Okay, so hypothetically, this key could have been used to forge tokens for any consumer service. Stormo 558 could have played your Minecraft game if they'd wanted to, right? They could have read your personal mail. They could have played your Xbox, right? They could have, depending on the service, they could have read data from other services, Microsoft services and other services that trust Microsoft keys, right? Anybody who had this validation error for this endpoint and used the endpoint could have been vulnerable, right? So the hypothetical impact is huge. And this is like saying, if I have a brick, I can rob any house in America. And it's true. I can break a window, I can take a TV, right? In practice, however, You don't, because you don't want your brick taken away, and you only have so many hours in the day. So you target your attacks. And this is an attacker that we know what they like, right? They had an objective. They had an attack objective. They had a powerful tool. They knew they had a powerful tool. They didn't want to get caught using the tool. They used it because they had a specific objective. And when they used it, fortunately, the first person that we heard from detected it, which was a big deal. So what do we have that gives us some confidence that the scope is what we say the scope is? Well, first of all, I want to be clear. We can't prove a negative. Like, aliens could have abducted, data or whatever. Like, we can't say for sure. But what we can say is that mail for 22 organizations and 502 consumers confirmed by monitoring of their traffic and their infrastructure by Mystic, and monitoring the actual traffic that's coming in from those IP nodes, reviewing all the logs, our capture of the actor's source code, correlation to previous observations of the actor, and the fact that they went back to phishing as soon as we rolled the keys. So those are all the things that give us some confidence that we have some understanding of the scope of the attack. All right, having cleaned that up, we published 2 blogs related to activity, and those were essentially telling you all the stuff I've told you using maybe different words, and a little bit less color on how the investigation teams experienced it. But again, those are all available to you at Storm 0558. And then we start, the thing that's really hard, right, is how'd they get the key? And I want to be very clear, this is an ongoing investigation, right? We are not done trying to find out. We may never find out, and I'll explain to you why that is. But this is an ongoing investigation as to how the key was acquired by the actor. And I'll give you, kind of our best understanding right now. When the attack happened, obviously it's an incredible priority for the company to figure out what happened, right? So we have red teams, we have pen test teams, we have all kinds of different people from all over the company jumping in to try to help us figure it out. And we started with kind of getting a brain trust together of the architects for identity, the architects for cryptography, and like what are all the things that could happen? And we come up with essentially 46 hypotheses, right? And these ranged from, was the person in this operational role an insider? Does this actor have access to a quantum cluster that we're not aware exists yet? And did they reduce the key? Were there problems with the issuance process, right? Like, could it have been possible for the workstation the key was being generated on to have crashed in the middle of that process, and could that have caused a problem? Could the nodes that the key is used by have crashed and exposed the memory that the key was in, right? So these are all these questions we're asking. For each of these work streams, we started, for each of these hypotheses, we started 3 work streams. One was investigate, go prove that it happened. The second one was detect, go prove you would know if it happened. The third one was prevent, go prove that it could not happen today, right? Detection and prevention are relatively easy because they're against current day systems, right? So you can say, in the current system, I have built this detection, right? In the current system, I've got this prevention. Because the teams were burning hard on this, we, in very many places, duplicated our detections, duplicated our preventions. And this is good. This is like solving the same math problem 2 ways and getting the same answer, right? We want to have as much redundancy and depth of defense as we can here. So we added huge amounts of new detection and prevention work covering all of the possible hypotheses that we had. In the process of that and investigation, right, we also identified some things that were impossible. I say you can probably take this hypothesis off the table. It just wasn't possible. There's others, like the reduction of the key, that we can't prove. We'll never really know whether the attacker reduced the key from a public key. We think it's extremely unlikely because had you the choice of keys to use, this is the key you would have chosen not to use, right? It's the wrong key for the scope and an expired key. It sticks out, right? And so you wouldn't want to use this if you're trying to avoid detection. So we didn't think that quantum was likely because we think if they had the quantum reduction, for example, they would have reduced the current enterprise key, not an old consumer key. But when you look at this, we get all these new capabilities. We eliminated some traffic, but the investigations path is harder. And the investigations path is hard because the systems are in constant evolution, right? We run red team attacks. We do bounty programs, we do pen tests, we do security evaluations, and we find things and we fix them on an ongoing basis, right? So we're constantly investing in the security of the system. The 2016 consumer system is basically nothing like the 2023 enterprise system. And it's not like it was just that system, it was that system in every evolution it went through, right? So we can go back and we can look at, for example, what are the fixes we took in the consumer system in that period of time to go find out what were the vulnerabilities we worried about in each of those moments and what were the things that were possible hypotheses, right? That helped form our hypothesis. As we went and looked through this, the things that evolved as the most likely, and I want to be very clear, this is a hypothesis. It is the most likely hypothesis. It is not a statement of how it happened, right? The most likely hypothesis became that operational failures around the time of key creation were the most likely explanation for how the key escaped secure containment. So the key should never leave the secure signing system, right? We don't ever want to see it out of that environment. It's got to be in the safe. The most likely explanation is that we had some sort of operational failure due to limitations of that system at that time, right? And so, for example, managed HSM did not exist in 2016, right? We did not have confidential compute in 2016, right? These are technologies that just didn't exist yet, right? We also had a fairly manual process in 2016. Our primary concern in the early days of the consumer systems were that we would have somebody reduce the key. So key rotation was based on the expected time it would take to reduce a key, right? And so, the long key lifetimes. In 2021, a couple of things happened, but one of them is this re-entry or entry into our environment, into the environment by Stormo 558. Right? So we think that in 2016, around the time of key creation is the most likely explanation for when we lost the key from containment, when it got out of the secure signing environment, most likely through operational failures. One possibility for that is that the system crash captured the key in plain text in memory, and the crash dump was exfiltrated by a developer with good intent. That's just a hypothesis. We showed to ourselves that that was a possible hypothesis because we found a race condition in the configuration for our systems which disable crash dumps for exactly this reason. But it was possible for the platform configuration to be run after our overrides. So it was just a sequencing problem at boot time, and it was possible that the system configuration would come in after our particular configuration, right? And so we fixed that, but that would have allowed crash dumps to happen. We found adjacent material for each of these hypotheses. We never found a plain text key in our system. We looked exhaustively for it. But that key, if it did escape the secure signing environment, did not just appear in 2016 and vanish. It appeared in 2016 and probably went into a database or into a file or into a mail or, who knows, right? Like it got into the environment, and from that point on, did somebody take a backup of it? We don't know, but once it's outside of the secure signing environment, the opportunities are broad, right? Once it's lost from that secure signing environment, we have this broad opportunity. So, Stormo 558 re-enters our environment in 2021. I say re-enters, I'm saying that incorrectly. They enter our environment in 2021, to our knowledge, the first time, right? And they do this using malware. They get a token from a device, and they manage to get a bunch of files. And the files they're looking for are specific to identity systems. So if the key were in the broader engineering environment for identity, if it was there because somebody had attached it to a database or whatever, passed it to somebody for help evaluating it, not by itself, but as part of a crash dump or as part of another body of work, right? Then that key could have been exfiltrated by the actor at that time. So this forms our most likely hypothesis. Key egresses in 2016 due to operational failure. Key is picked up by the actor in 2021. Why aren't we sure? Why didn't we find it? Because we're constantly also building more CRED scanning and more cleaning processes. So when developers make a mistake, we automatically correct that mistake for them. If they check in, a certificate as part of their code check-in, we wipe the certificate, right? Or we block the check-in and change the data. So we have these sweeper processes, and the sweeper processes are constantly going through the environment, and they're constantly getting better. So the sweeper that missed the key in 2017 might have caught the key in 2022, making the investigation even harder. Like we're literally removing this data, and logs aren't retained forever, so some of the older logs are gone. This is why I say we may never know, right? We may never actually be able to land it. We did very heavy investigation, but this combination of continuous improvement and evolution of the system and continuous sweeping and cleaning of the system to harden the system is actually making this investigation harder to do because of the latency here. So in September 6th, we thought, okay, we've exhausted all of the logs. We're not finding anything else. And, we had these very strong conversations about, and I'm very clearly on, the side of like, let's publish, let's tell people where we're at, let's tell them what I just told you, right? And so we wrote a blog that explained what we believed was the truth at the time. Like we said, we've done these investigations, this is what we found. There's one material mistake in the blog. We said we had a crash dump with the key. We did not. That's the material thing that changes. However, it doesn't change the scope of impact. It doesn't change the guidance to customers, right? It doesn't change anything about the material hypothesis about what went wrong in the system or what we've done to fix it. And for those reasons, we thought we had a discussion about when to update. And the discussion was, let's update when we have a complete conclusion, because we've opened other lines of investigation now. And the idea was like, let's update when we have a complete conclusion. We talked about all this with CSRB, and when we knew they were going to publish, we said, well, we better make sure people understand that that line was materially incorrect. So we updated the blog on March 12th. The response here is been noisy, I think, in the press. We obviously, have been responding continuously to advanced persistent threat actors for years and have been ramping up. We have, I think, a new level of response at this point. And the response here is really, in this very nice mail from Friday that Satya sent to every employee at Microsoft. Very simple. If you have a trade-off, do the security thing first, right? So this is the Secure Future Initiative. There's been a fair amount of press on it, and so I'm not going to talk about it in a huge amount of depth. But I think this is the most important thing, is that there is a fundamental shift in the way that we are thinking about security as just unambiguously. There's not like, well, this is a smaller issue. Like, just fix the security stuff, and then the rest can go on. So from the perspective of the security teams, of course, that's huge empowerment. Secure by design, secure by default, secure operations, kind of the things that are important in terms of the thematics. We're doing paved path systems, so we've done a bunch of work like security defaults and managed policies to try to make your life easier in terms of rolling out multi-factor auth or passkeys or whatever. Think about from a developer's perspective. The easiest thing to do is what they're going to do. Make sure that's an absolutely secure thing that we can actually update as we go, right? So commonalizing and securing systems and making them really easy. That easy part's important. If you give people high friction, high security things, they'll find low friction, low security things to do, right? We're not done. We talked about SFI in November. We're talking about it again now. We'll talk about it again later. I'm sure we will learn more and do more. We're a learning culture, so I think continuous improvement is part of it. There are 6 major pillars. Lots of them track to what I've been talking about here. The one I want to talk about just briefly is on identities and secrets. The work we're doing here around moving keys to HSM. We're starting to move to stateful tokens, which basically means every time you get a token, you call the token introspection endpoint, and you say, hey, is this okay? It reduces your reliance on key material. It also gives you better real-time reaction speeds. Common libraries across the board so people can't make validation errors, keeping those libraries current. The movement to secure memory management like confidential compute and managed HSM so that the keys just can't be exfiltrated. We already have done full automation of the key management process, so we've removed human error from the equation. So this is all the kinds of stuff that we're doing in response and on ongoing long-running response. If you're waiting for identity features, you may be waiting slightly longer. If you're waiting for any features, you may be waiting slightly longer, right? But the net effect is essentially snapping everything to current standards and then keeping it there. And then the sort of the moral of the story is this. I think that I get this question a lot, which is, hey, how do you feel about the report? And I think that the response was exactly the right response, which is let's lean into it. What can we learn from it, right? So we went and we, do you want to testify? Yeah, we do. Because we believe strongly that we can't stand in isolated silos as an industry and withstand attacks by, nation states or nation state affiliated organizations. Like, we're not going to succeed, right? We'll get picked off one by one. So the key here is how do we stand shoulder to shoulder better? And in the industry, the way we do that is we go, hey, this happened. Like that's the point of this talk, right? You can learn, how did we experience it? What were the things that led to this? Charlie said recently, he says, every every accident, every failure is preventable, right? Every accident is the sum of a set of parallel failures. So you can look at the parallel failures in the situation. If we study those, and I think what the CSRB is trying to do is to study these things and, like the NTSB, get to a place where we can say, hey, the whole industry can implement what we learned from these things. So when I was asked just recently, like, how do you feel about that report? I was like, it's fuel, man, it's great. We're gonna push ourselves harder. We're gonna learn more, right? So we're enthusiastic participants in the report. We're enthusiastic, frankly, about leaning into the recommendations in the report and more. The growth mindset here, this is not an admonition to you, it's a reminder for us, right? We believe in the growth mindset at Microsoft, and this is an opportunity for us at Microsoft to lean into that growth mindset and say, okay, what can we learn, from the event? What can we learn from the recommendations? What can we learn from the industry's, essentially triangulation of that data? And so I think that's the moral of the story, right? If we stand together and we can share data and we can be unafraid to show, where things happened, then we can get better as an industry. We have a better chance of resisting these really, really well-funded, really persistent attackers. And with that, I think I will say thank you very much for your time, and hope you guys have a great rest of your conference and journey home. Also, yeah. All right, thanks a lot.